Welcome to this explainer. Look, today we're going to decode the invisible chemical world that dictates the absolute health and survival of your goldfish. We're breaking down exactly what's happening in your aquarium's water and giving you the exact step-by-step laboratory protocols to monitor it like a pro.
So, let's kick things off with a foundational question. Why on earth do goldfish, which, let's face it, are so often misunderstood as these super easy beginner pets, actually demand such rigorous water monitoring? Well, the answer lies in their unique biology, which makes their environment incredibly volatile if you aren't paying close attention.
Here's our roadmap for today. We'll look at the reality of the goldfish bioload, the invisible nitrogen cycle, mastering the API test kit, conquering that tricky nitrate test, and finally, mineral hardness and pH. Let's get into it. All right, Section 1, the goldfish bioload reality. We've got to shatter this classic low-maintenance bowl pet myth right out of the gate. Unlike a lot of tropical fish, goldfish actually lack a true stomach. They're designed to graze constantly. Think of them like aquatic cattle, honestly. Because their digestive system is so fast and inefficient, they produce a massive, high-impact bioload. Basically, they are continuously pumping incredible amounts of unseen waste straight into their water.
And that brings us to the ultimate danger here. Crystal clear water will trick you. Seriously, you literally cannot judge the safety of a goldfish tank just by looking at it. The water might look absolutely pristine to the naked eye, while these invisible, lethal toxins are rapidly building up right under your nose.
Which leads perfectly into Section 2, the invisible nitrogen cycle.
To really understand these invisible killers, we have to follow this biogeochemical timeline. When you set up a tank, you're relying on beneficial bacteria to process all that toxic fish waste. From day 1, your goldfish is excreting toxic ammonia. Then, by about week 2, certain bacteria start converting that ammonia into nitrite. And finally, somewhere around week 4 to 6, different bacteria convert that nitrite into nitrate. You have to monitor this invisible cycle, or you have no idea if a safe environment is actually established. So, what does this all mean when the cycle breaks down? Well, the threats are severe. Ammonia is highly toxic. It literally burns their gill membranes and causes them to gasp at the surface. It's awful. Nitrate is just as insidious. It actually binds to the hemoglobin in their blood, effectively suffocating them from the inside out. Then you have nitrate. It's the final stage, and yeah, it's the least toxic, but if it climbs above 40 parts per million, it causes chronic stress, suppresses their immune system, and triggers massive algae blooms. This right here is exactly why regular water testing is an absolute necessity, not just an option. All right, moving on to Section 3, mastering the API kit. Now that we know the biological stakes, we need our diagnostic tool. Enter the API Freshwater Master Test Kit. Instead of using those kind of inaccurate paper strips, this kit uses colorimetric analysis. By adding precise chemical drops to your water sample, the resulting color changes reveal the true unseen condition of your aquarium. Okay, before we drop any chemicals, we really have to nail down some strict laboratory protocols. First, you've got to hit that exact 5 milliliter line. The bottom of the water curve needs to rest right on it. Second, flip those reagent bottles completely vertical, like fully upside down, to make sure your drops are totally uniform. Third, always use the provided cap to shake the tube. Popping your thumb over the top can actually contaminate the results with your skin oils, or even alter the pH. And finally, rinse those tubes out immediately after testing so they don't stain. Let's start with testing for that highly toxic ammonia. Using a precise 2-bottle salicylic method, you're going to add 8 drops from bottle number 1 and then 8 drops from bottle number 2. Cap it, shake it vigorously for 5 seconds. And here's the hard part. You got to wait exactly 5 minutes. You're looking for a yellow result, which means 0 ammonia. If it turns green, no way. Your fish are in immediate danger. Next up is the nitrite test. This one is way simpler, actually. It just requires 5 drops of a single solution. Cap it, give it a quick 5-second shake, and again, wait those 5 minutes. You want this water to stay light blue. If it turns a dangerous purple, your biological filter just isn't working fast enough to keep up. And the final step for all these tests is reading the results. To get an accurate reading, you have to visually match your test tube directly against the white background of the API color chart. Hold it up in a well-lit room. That strong contrast is exactly what gives you your precise parts per million reading. Now for Section 4, the tricky nitrate test. Because there is one specific test in this kit that catches almost everyone off guard.
If you have a heavily stocked goldfish tank, especially one that's been running for months, but your nitrates miraculously read 0, well, you haven't achieved a miracle. You're actually likely making the single most common user error in water testing. The secret here lies in bottle number 2. The active reagent in this specific bottle is actually a suspension of crystals, and they settle solidly at the very bottom. The sources emphasize that if you fail to aggressively bash and shake this bottle, you are practically guaranteed an inaccurate false 0 result. So here is your bulletproof protocol for this one. Step 1, add 10 drops of bottle 1 and invert to mix. Step 2 is the real workout. Vigorously shake bottle 2 for at least 30 seconds. Honestly, bang it on a table if you have to. Then add 10 drops from that bottle. Step 4 is totally unique to this test. Cap the actual test tube and shake it like crazy for 1 full minute. Then wait your 5 minutes. If it turns yellow, orange, or red, you finally have an accurate nitrate reading.
Finally, Section 5, Mineral Hardness and pH. Beyond the nitrogen cycle, we also need to test the invisible minerals that keep your goldfish's environment stable. To measure general hardness and carbonate hardness, you won't use the standard master kit. You'll actually use a separate specialized API kit that relies on a method called titration. Instead of adding a set number of drops and waiting, you carefully add 1 drop at a time, inverting the tube after each drop and literally counting them until a very distinct color shift occurs.
Think of these 3 parameters as your tank's life support system. KH, or carbonate hardness, is your shield. It buffers the water to prevent rapid, deadly acid spikes. GH, or general hardness, provides the raw calcium and magnesium goldfish actually need for bone growth and proper internal fluid balance. And pH measures acidity. Goldfish thrive in slightly alkaline water, ideally between 7.2 and 7.6. But why does KH matter so much? Well, if you fail to monitor it, you risk old tank syndrome. You see, the biological processes in a tank naturally consume carbonates over time. If your KH hits 0, you completely lose your buffer. This causes a catastrophic event where your pH plummets, your beneficial bacteria die off, and massive ammonia spikes can just wipe out your fish. Monitoring your KH and keeping up with regular water changes replenishes those carbonates and totally prevents that disaster.
Okay, here is your master cheat sheet. You might want to take a screenshot of this one. To ensure a thriving habitat, your ammonia must be 0. Your nitrite must be 0. Your nitrite should be kept below 40 parts per million with regular water changes. Your pH should be stable, right around 7.2 to 7.6. And your GH should show plenty of minerals, usually between 200 and 400 parts per million.
So, I'll leave you with this final thought. Keeping goldfish isn't about guessing or just waiting for the water to look cloudy. Are you going to wait for your fish to show symptoms of distress and disease? Or are you ready to use these exact laboratory steps to master the invisible world of your aquarium? Grab your test kit, follow the protocols, and take control of your tank. Thanks for hanging out with me for this explainer, and happy testing.